Welcome to the 1986 Nobel Prize in Physics. This was a divided prize, but it's one of the ones where we have to just kind of agree that they're just going to science the shit out of this thing till it works. So one half of the prize went to Ernst Ruska, who won for his fundamental work in electron optics, which led to him being able to design the world's first electron microscope. And he did that in 1933. I mean, think about that. 1933 is so long ago. It was the first one. It wasn't as good as the ones we have today, but it was the first. The other half of the prize was split between Gerd and Heinrich Rohrer. Hope I'm pronouncing those names correctly. From actually the IBM research labs, and you can see them here. And what they built was the world's first STM, which was the scanning tunneling microscope, which gave you a much better resolution than what you got with the previous electron microscopes. Now, with these two types of scopes, with the original electron microscope and the STM, you get a surface image, but you get a surface image down to some ludicrous level. And in fact, you can see individual atoms. And as you see, in some images, you'll see individual carbon atoms, like here in a carbon nanotube. And the carbon nanotube that you see there, they're about like a nanometer across. Those shiny spots are actually what you see is the electron cloud of the carbon atoms. So it's, you're not actually seeing the nucleus, but you're seeing the electron cloud as it orbits around, 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 and it shows up as shiny because it's highly conductive. So that's where we have the STM. Now, STMs after that were actually extended to where you can use them to sort of place individual atoms in different spots. So you could actually say, okay, I want to put this one here, I want to put that one there. And some researchers at IBM Labs actually did that for the first time and spelled out the word IBM with xenon atoms right there. You can see a couple other errant atoms got stuck on the surface, but that's the way it works. Electron microscopes are used for a lot of other stuff too. You can actually tell atomic makeup of things. You can do all sorts of work with them that really do help researchers kind of figure out what's going on. The thing I always used them for was when I worked with nanotechnology was to try to figure out just where the nanotubes were in different structures. So if you're trying to make like a composite material, you're not sure where certain structures are sitting, you want to go in and get a really close-up image of trying to figure out where everything went. And the trouble is if you're doing like a composite, like a big sheet of foot by foot long metal, you're not going to look at all that with an electron microscope. It's too big. But you can look at specific sections and say, okay, did I get uniform distribution of my carbon nanotubes throughout that entire material? And well, who cares, right? It's just carbon nanotubes. Who cares? Put them in there, whatever, right? Now, the deal with those things is they're 100 times stronger than steel and they're lighter than aluminum. So if you got like a plastic material and you want to make it stronger, adding some of those can be a great way to do it. Carbon composite's been around forever. Well, these are carbon nanotubes, and they make it even better than just a carbon composite or carbon fiber composite. It's sort of the world's most advanced version of a carbon fiber composite. Really good for different things. But with the electron microscope, we can't really tell what the thing looks like. We have to do a ton of lab testing on other stuff anyway. But it really does help you in those first early days of figuring out what's going on. And with that, you can image the individual atom, which it's just a cool thing to go do. So these things do make a big difference in early stage research projects. They do make a big difference in even forensic science in some ways. But you're not going to find one at Home Depot that you could take home with you because they're really a little more complicated to use than that. But they're really cool instruments, and they weren't around forever, right? So the first one was 1933. IBM didn't start building the really good ones until the 1980s. And now it's just 2024, about to be 2025. We're getting down to where imaging individual atoms almost seems routine. It's not, but it seems like it from the outside looking in because you're like, hey, we've imaged atoms before. That's long gone. It's not as easy as it sounds. You have to be very careful with your instrument, and it takes hours of painstaking work to get down to where you can see the individual atoms, but it can be done. And thanks to these guys, we now have that capability, and it's pretty cool stuff. So if you want to learn more about electron microscopes, I would Google IBM Research Lab or IBM and scanning tunneling microscope. Those are, in my opinion, the coolest ones from the early days. And modern STMs are even better than those. But the earliest days in the 80s and 90s were mostly IBM Research Labs doing some pretty cool stuff with them. A lot of universities did it too. I don't want to take away from them, but IBM kind of led the way. In fact, the two guys who shared half this prize worked for IBM when they did the work that won them the prize. So that was the 1986 prize. We'll see you on the 1987 prize. Don't forget to click like and subscribe, and we'll see you soon.